All right, Michelle, I know packing is really important when it comes to putting up pretty much any crop into a storage structure, but what are some other management tips that you can give us on high moisture corn to really limit our shrink?
Yeah, really the best way to limit shrink and the best way to avoid spoilage is going to be preventing oxygen from getting in. So like we said, packing will squish out the oxygen, but another great way is wrapping the sidewalls. And this farm did a wonderful job of that, especially if you have concrete blocks as your sidewalls, you have a higher chance of oxygen infiltration. Using an oxygen barrier plastic, this farm, I took a sample, used some silostop plastic, and that's going to help keep the oxygen out of the silage, especially in that top layer. Inevitably, some people may have spoilage in the top layer. Just pitch that off if you can safely. And as well, keeping out a good feed out rate. That's really important because oxygen is going to infiltrate that face of the silo no matter what, and you want to stay ahead of that. So that means in a bunker, 6 to 12 inches, 6 being in the winter, 12 being in the summer. And then for an upright, 4 to 8 inches, and that's feed out rate per daily. And finally, I think one of the best ways to prevent spoilage, besides everything we've mentioned, is to use tires and make sure you're using enough. Keep those tires touching.
Hey Michelle, let's talk a little bit about temperature. What's really your best suggestion on what these temperatures should look like in these feeds?
Yeah, temperature is a big deal because I consider temperature to be the biggest way to know is your silage spoiling. And when you use a Buchneri-based inoculant, is your inoculant working, because you shouldn't have heating. And so again, I like to keep things simple stuff, and I like to just use a thermometer. This is just a regular meat thermometer. Stick it in your silage. How hot is it getting? And so I usually like to see within 10 to 15 degrees of whatever the ambient temperature was whenever it was ensiled. So if we ensiled this at about, 50 degrees, we're right here at 60 degrees, and that says to me that there was a fermentation that produced a little bit of heat. That's good. That's what I like to see, but it wasn't excessive. If you think about this as a swimming pool that's made of a lot of water, how much energy would it take to heat up your swimming pool that's 30–40% water? It's going to be a lot of energy, and that's energy stuff that should be going to feeding the cows and making milk, but instead it's being turned into heat and just being blown away.